Hey everyone, this video is dealing again with fractions, and this time it's going to focus on multiplication and division. One of the big differences between multiply divide compared to adding and subtracting is multiply and divide does not need a common denominator. Do not even do a common denominator. It'll make it more complicated than it has to be. It also, you can reduce fractions in the middle of a problem, and that way you don't have to reduce at the end. So we're going to look at some problems with multiplying, then we'll look at dividing. So first, let's start with some multiplying. Let's say that we have 2/3 times 1/3. Now, yes, I know these have a common denominator, but that doesn't really matter for anything. The main thing with multiplying, and with dividing as well, is we multiply straight across. Multiply, multiply. Numerator to numerator, denominator to denominator. So when I do this, I get 2/9. Simple enough. We go straight across and reduce if we have to. You can always do that if you need to, but you want to be careful because you don't always have to. Let's say that I have 3/5 times 4/9. Now, I could just multiply across, which would end up giving us, and I'm going to leave it in red here, just so that you know it's a slightly different answer. That would give us 12/45, which we would then have to reduce, which would end up bringing us down to 4/15. But we don't have to do it that way. We can look at numbers in the numerator and numbers in the denominator and see if they have anything in common. Now I've got a 3. Now as long as it's multiply, they don't even have to be in the same fractions. 3 and 5 have nothing in common, but 3 and 9 do. That means I can cross out the 3 and make it a 1, and it goes into 9 3 times. I can reduce it even though they're not vertical. 4 and 5, nothing to do with each other. So now I can just multiply across. 1 times 4 is 4. 5 times 3 is 15. Let me fix my 4 there. So notice we got the same number, 4/15. We reduced earlier the second time. The first time we waited to the end. I always like to reduce earlier in the problem, but that's up to you. It does not matter. Now let's say that we have -2/5 times 15/16. Let's separate the screen here, just so you can see them. Now, I'm going to simply reduce here at the beginning. That's what I'm going to do. That's what I always do. Notice I've got a 5 and a 15. They have something in common. 5 goes into 15 3 times. Then I have the 2 and the 16. Notice I ignored the negative sign on purpose. 2 goes into 16 8 times. So when I multiply across, so I'm multiplying here and here, so times and times, I'm going to end up with 3/8. Now just like we did with mixed numbers, that negative sign just moves to the end. Remember with multiplying, if you have one negative in a multiply problem, your answer is negative. If you have two, the negatives cancel and turn positive. Odd amount of negatives, negative. Even amount, positive. So now let's look at division. Division is a little bit different. We've got to use a phrase that I like. Keep it, change it, flip it. This is a phrase that I've used in classes, that I've heard in classes, and it seems to work pretty well. Let's say that I have 4/5 divided by 2/3. We're going to use an old quotient symbol. So now keep it deals with 4/5. Change it deals with the division. Flip it deals with the final fraction. So we keep 4/5, 4/5. We change the divide to a times, and we flip or take the reciprocal of 2/3, which is 3/2. Now I can look and see if there's any canceling. Well, I've got 2 and 4. 2 goes into itself once and into 4 twice. So then when I multiply across, I end up with 6/5. And it is simplified, so there's my answer. You can't actually do the division. You've got to make it a multiply problem, which means that you're going to multiply by the reciprocal. It's called a multiplicative inverse. So we're going to keep it, change it, flip it. Let's look at another one. Let's take -3/8 and -9/4. Now I used a different symbol set here. I used a complex fraction. That's a fraction within a fraction. In this case, two fractions within a fraction. This middle bar right here just simply means we're going to divide the two fractions. So that means I'm going to keep the first. I'm going to flip that to its other operation, or change it, and then I'm going to flip that. So that means -3/8 times 4 -9. Now the negative sign doesn't matter whether it's top or bottom. Since there are two of them, we know that they're going to end up canceling out. They're going to be gone. So now I've got 3 and 9, so that's going to be 1 and 3. I have 4 and 8, so that's going to be 1 and 2. So that's going to give us an answer of 1/6. Again, you could have multiplied 4 and 3 and 8 and 9 and then simplified the 12/72, but I think it's easier to cancel earlier on. So we're going to do one more problem. So let's say that we have, now this one's going to be a combination. Let's say 2/5 divided by 10/12 times 1/6. In this case, I've got a divide and a times. So I've got to keep that. I've got to change that. I've got to flip that. But the last part, the times 1/6, stays by itself. We don't adjust that at all. So 2/5 times 12/10 times 1/6. Do not cancel back with the divide. You got to wait. Now, I've got 12/10. I could reduce that. I'm going to just ignore it. I'm going to notice that I've got a 12 and a 6 that I can cancel. So that's 1 and 2. Unfortunately, the 5 and the 10 are on the same line, so you can't do anything about them. I also have a 2 and a 10. So that's 1 and 5. I could have also done the other 2 with the 10. Wouldn't matter. So I multiply across the top. 1, 2, and 1 is 2. Then 5, 5, and 1 is 25. And that is simplified, so it is reduced. The biggest thing here is the reducing and the canceling. Do not multiply diagonally. You multiply across, but you cancel top and bottom. So just remember that if you need to go back and look, just pause the video, go back and look at what you need to. Go back to the mixed number, the adding, the subtracting with the common denominators, whatever you need.